So in today's video, we will discuss about Malu's law. For that, let me consider a polarizer like this, and let this be the plane of the polarizer, which means this is the plane of transmission of the polarizer. That means through this plane only the polarizer will transmit light. What this polarizer will do is, if we have an unpolarized light coming from the left like this, an unpolarized light basically means a light which has vibrations in more than one direction, like this. If this is the y direction and this is the z direction, we know this light has directions in z direction and y direction. So it is an unpolarized light. Unpolarized light. That means it has vibrations in more than one direction. So what a polarizer will do is, it will transmit the light only in one direction. So here it will cancel the vibrations in this y direction and it will transmit only vibrations in the z direction. Okay. So this is a polarized light. Polarized light. So the material which is doing this is called a polarizer. Polarizer. Clear? Now we need to check whether a polarizer polarized light or not. For that we use an analyzer. See, we are talking about, we need to derive an expression for Malu's law. Okay. So we are not getting into the definitions of analyzer and polarizer. Okay. If you want to know the definition, we'll do another video. Okay. So let's take an analyzer in here. Let this be the analyzer. And now I just rotated the plane of transmission like this. I just tilted the plane of transmission. This is an analyzer. Okay. Analyzer. It also is a polarizer. Now I just tilted its plane because this is, see, this is the plane of transmission. Or the original plane of transmission was like this. Let me represent that using a dotted line. See, this is the original plane of transmission. Now I tilted it through an angle theta. Let this be theta. So this is the direction in which the light gets transmitted. Okay. Now we never get this same amplitude through this plane because we have tilted the polarizer, or sorry, we have tilted the analyzer through an angle theta. So the amplitude also changes. So let A0, A0 or A0 be the initial amplitude, and we know that the intensity is always proportional to the square of the amplitude. Okay, we always have the intensity proportional to square of the amplitude, or I can write, let me take the initial intensity, or in the intensity of the polarizer be some I0. So I can write I0 is equal to some k times, if you remove the proportionality, you have to multiply with a constant. So k0 a square. Let me call that as equation number 1. Now consider this analyzer. Let me draw the plane of transmission and the initial plane. See, this is the initial plane, that is the dotted line. Let me mark this point O. So this is our O. Now our new plane of transmission is this. Okay. So what is our initial amplitude? This is our initial amplitude. Clear? That is this one. See, this is the initial amplitude. Let me mark as A0. Now I need to find the amplitude through this plane. That is, let me mark this as 1. So this is our 1. This plane as 2. So this is our 2. So I need to find the amplitude through this plane, and we know this one is theta. For that, let me drop a perpendicular from this point to this plane of transmission. So this will be 90. And this length will give, let it be 80. So this length will give the amplitude of amplitude through the transmission plane. Okay. See, once again, this is the amplitude through the initial plane, that is this one, and I have tilted that plane through an angle theta. So this is our new transmission plane, and 80 means the amplitude through the new transmission plane. Now if I take cos theta will be, see, adjacent side. See, this is the adjacent side. So 80, the length 80 divided by the hypotenuse. The opposite of 90 is the hypotenuse. So A0. Now the amplitude through the transmission plane, if I take this to the left, I'll get A0 cos theta. And we know the intensity through the transmission plane is proportional to the amplitude through the transmission plane, AT square, like we did here. Okay, so expanding this, you'll get IT is equal to some constant K into AT square. Okay, if you remove the proportionality, you have to multiply with a constant. So this will give IT is equal to K into, instead of AT, I can put this value. Okay, so A0 cos theta square. Okay, that will give IT is equal to K A0 square cos square theta. Okay, squaring both the terms. Now we know K A0 square is our initial intensity. So we will get I equal to, the intensity through the transmission plane is equal to initial intensity. See, this is I0. I0 cos square theta. And this is called the Malu's law. Clear?